Okie dokie, let's go ahead and get started on our Unit 5 final review. The first thing that I need you to remember that we talked about back then was, what did you do with negative exponents or exponents to the power of 0? If you've forgotten, it's the opposite of one group of multiplication. Instead of us having one factor of 5 multiply, we're going to have, this means we're doing the opposite of multiplication. The opposite of multiplication is division. And the easiest way to write division is 1 divided by 5. You write it as a fraction. Some people like to think of this as, if I have a negative exponent, it means you have one group of 5 in the denominator. That's an easy way to think about it. So 5 to the negative 1 is 1 over 5. And before I forget, since you can use your calculators on your actual test, these calculators do know how to do 5 to the negative 1 power. If you type that in, let me see if I can get it to show up here. Equals. Look at how beautiful these calculators are. I've shown you this before, but let me remind you, do not be afraid to use the negative button on the calculator, which is right there. It's different than the subtraction key. And you can do that in the exponent, and your calculator will know what to do in case you forget. And so you could do all those problems that are up there with your calculator if you need it on the test, right? Okay. There's a question like number 2. Number 2 was not in our notes from way back in the way back when we did Unit 5. But if you don't know what these words mean, you will not know how to answer one of the questions on your final. For example, if choice A was all positive integers, if choice B was all negative integers, if choice C was all integers, and if choice D was all real numbers, you might get a question wrong if you don't know what those words mean. So let's talk about the word integer. Means whole numbers. So if we say negative integers, we're talking like negative 5, negative 4, negative 3, negative 2, negative 1. Those are negative whole numbers. If it says all integers, we're talking about the negative integers, the negative whole numbers, 0, and the positive integers. All integers means everyone. Positive integers, on the other hand, are like 1, 2, 3, 4, 5, on up to infinity. All real numbers means that we can have fractions, we can have decimals plus the integers. You could even throw in pi in there or the square root of 2. It doesn't matter. So make sure you know the difference between an integer, whole numbers, and real numbers. That means every single number. When I count the number of students in here, I use an integer. Why do I use integers when I count for students? Because I don't have 1.5 students. I have 33 students in here. That's my guess. I could be wrong. Just so you know. Okay. Then we talked about graphing. Some of our equations are 2x. 2 times x plus 0. This is y equals mx plus b. This is your slope. This is your y-intercept. This is how you would graph y equals 2x. If you don't know how to do it, make a table and plot your points. If you've forgotten what domain and range means, domain means what are your x values? What values of x do you use? Do you use 1? Do you use 2? Do you use 3? Do you use negative 1? Do you use negative 2? You use all real numbers, including the fractions, because this is not discrete, it is continuous. And then for something like this, where you have y equals 2 to the x power, you can make a table. You can plug in x is 2, and x is 1, and x is 0. Use your calculator, and you'll get these values, which creates this exponentially increasing equation. These values are always, these y values are always bigger than 0, so the best way to write the range is y is greater than 0. And then this would be shifted down 3 for that other graph that's right there. So if you've forgotten, when you deal with graphs, what you should be doing, if I ask for a solution means a point that is on the line. A point that x, if you plug it in, will equal that y value. Like if I plug in the number 1 right here, 2 to the first power, I get the y value of 2. It's the only answer that works, where you plug in that x and you get a y. As you do problems, if you can get an answer, 2 to some power is equal to 8, there's one real solution. Because I can plug in, I know x has to be 3. But if you're trying to plug in numbers and you're trying to get a negative and there's a power here, 3 to some power equals -7. If I plug in -1, it's going to be 1 over 3. It doesn't work. There's no way I can get to -7. That's why there's no real solutions there. Sometimes there are no real solutions. Sometimes there are infinitely many solutions. The last idea that was on here, the number 6, if you have one equation that's 3 to the x, that makes this graph, this exponentially increasing graph. And you have one graph that's 4x plus 1, which makes this linear graph. Where are they equal to each other? They're equal to each other in 2 spots, at 0 and 2. And I can prove it to you by plugging in 0 here and by plugging in 2 there, and I can get that the values will be the same. So that's how I worked that one out. Turning the page over, the back side. You may have forgotten how to find the average rate of change. The average rate of change is where you take y2 minus y1 over x2 minus x1. So I took this y value, subtracted that y value, divided by this y value, subtracted by that x value, x value minus x value, and you get, in reduced terms, it's an average of 4 on your average rate of change. Now, the rate of change for a linear graph is going to be way different than for an exponential graph. Sometimes you're going to plug in numbers like 5 to the 4th power is 625. Make sure you know how to do that on your calculator. That's a big number. Let's talk about growth and decay. If something gets bigger, it's growth. Something gets smaller, it's decay. How do we know if it's going to be growth or decay? It depends on the base, the number at the bottom of the exponent. If the number at the bottom of the exponent is bigger than 1, then it's growth. 1.09. That is growth. By how much? By 9%. The base is 6. That is growth. It's getting 6 times bigger every single time. 1/3, on the other hand, is smaller than 1. This is going to be 1/3 of 1/3 of 1/3. That means you're dividing it by 3. It's going to be decay. It's going to be smaller. How come? Because 1/3 is less than 1. I only care about the number at the bottom of that exponent, whether it's growth or decay. Let's talk about interest. If something does 8% interest, you never just put 8. You change this to a decimal, but you have to add 1 to it. It's 1.08. How come? Because otherwise, you're only calculating the 8% without calculating the original amount as well. Think of it like this. $1,000 times 1 gives you $1,000. Plus $1,000 times the 0.08 gives you the interest plus the original amount. Do not just put down 0.08. Make sure you add 1 to whatever your rate is. Few other things that we did is we solved for how many passengers. What is the probability that a driver in a car will get into an accident as a function of the number of passengers in the car? What is a reasonable domain for P of X? What that's asking is what do you think are a reasonable number of passengers in a vehicle? Reasonable. Does everybody drive a charter bus? No. Think about the car you drive or the van you drive. Think about the car you drive. What would be a reasonable amount of passengers. That's how come I picked B, because it was a nice whole number. And then we had explicit formulas and recursive formulas. If you don't remember those will be given to you on the test on a formula sheet. So don't freak out about those. I'm going to stop your recording right there.